Hey guys, this is Mrs. Harbin and this is Advanced Math 2.6. Today we'll be looking at solving systems of equations, specifically solving systems of inequalities. Let's take a quick review of inequalities. Graph each inequality on a number line. I think sometimes students forget that we can graph on a number line, so hopefully you remember how to do this. We see that x is greater than or equal to -2. This greater than or equal to tells me I need a solid dot on the -2, and greater than goes to the right. Greater than, remember that R there, greater than goes to the right. So our graph looks like this. All of these values are greater than or equal to -2. What about x is less than or equal to 3? How would you graph that one? If you set a solid dot on the 3 and the arrow pointing to the left for less than, nice job. Go ahead and graph each inequality on a number line. We have x is greater than or equal to -2 and x is less than or equal to 3. When we have a system of equations here, we graph both equations individually. So x is greater than or equal to -2, x is less than or equal to 3, and our answer is the part where our two graphs intersect, in this case between -2 and 3. In this lesson, you, the student, will graph systems of inequalities on a Cartesian plane, not just a number line. When you graph an inequality, the shaded region represents all possible solutions, because we know with an inequality there's more than one possible answer. The solution to a system of inequalities consists of the ordered pairs that satisfy all the inequalities of the system. So here's how you solve a system of inequalities. First, graph all inequalities on the same set of axes. Then, find the solution set where the shaded regions intersect, and check the result. Now, it's possible you've forgotten how to graph inequalities in a Cartesian plane, so let's go through these really thoroughly to make sure you remember how to do them. So we have two inequalities. 3x plus y is greater than 4, and x minus y is less than or equal to 8. Well, in order to graph these, just like graphing a line, we want to put them in y equals mx plus b format, or y inequality sign mx plus b. So that's our first step. Once we have them in slope-intercept form, we're going to go ahead and graph them just as we would a line. Our intercept for the first equation is 4, and our slope is -3. And we're going to shade above the dashed line. Because this is not an equal to inequality, we can't have a solid line. Instead, we're going to have a dashed line. Our slope will be negative. And because it's greater than, we're going to shade above. Greater than is above the dashed line. On the second equation, our y-intercept is -8, and our slope is a +1, so our slope will be going this direction. It is greater than or equal to, so we have a solid line, and we're going to also shade above the solid line. Let's put those on a graph and see what they look like. Here is our first line. Our y-intercept is at 4, and our slope is at -3. Dotted line, and we've shaded above it in red. For our second line, we have our x-intercept is 8. Our slope is a +1. It's greater than or equal to, so again, we've shaded above it. And our solution is going to be where these two shaded areas overlap. So the answers that fit both solutions here is this region where pink and blue overlap. Take a look at this system of inequalities and solve these. We have x is greater than 0, y is greater than 0, and 2x minus y is greater than 1. Let's begin with the first two inequalities. X is greater than 0 and y is greater than 0. We can't really put these in mx plus b format because it's just one variable with a letter. So we're going to shade to the right of the dashed line at x equals 0 and shade above the dashed line y equals 0. So here is our first equation. X is greater than 0. So here are all of our x values greater than 0. And y is greater than 0. Here are all of our y values greater than 0. Where these two regions overlap is the first quadrant. So already we have solutions that we know will only be in the first quadrant. But now we're going to add a third equation to that, which is 2x minus y is greater than 1. We're going to solve that, or put that in y, inequality sign mx plus b. Now, if you're wondering how we went from greater than to less than, just a reminder, when we move the 2x here, we get negative y is greater than negative 2x plus 1. And to get rid of that negative y, we've got to divide by negative 1. And when you divide an inequality by a negative, it flips that sign. So that's how our sign got flipped there. Our y-intercept is negative 1, and our slope here is 2. And because it's less than, we're going to have a dotted line, and we're going to shade below that line. So our slope is a positive 2. It's dotted, and we're going to shade below that line. Okay, it will look like this when it's just by itself. When we overlap it with the first two things that we had, we know that our answer is only going to be in this first quadrant. So even though this equation also gives us answers down here, those answers don't overlap with the first two inequalities. So this right here is our solution to those three inequalities overlapping. Okay, let's graph the system y equals negative 4 and y is less than or equal to negative 3 plus 1. And you can see those two equations here. The first one is red, greater than or equal to negative 4, so solid line, and we shade above. Less than or equal to negative 3x plus 1 is a solid line as well, and we shade below. And then the area where both of those intersect is this very sloppily shaded region right here. Today we graphed systems of inequalities, and we discovered that the shaded area where our two inequalities intersect is the solution to our system. If you need some help graphing inequalities, you've forgotten how to do it on a number line or on a Cartesian plane, make sure you ask me for help next class.